Okay, we have been discussing how to solve systems of equations. We're going to switch gears just a little bit, and we're going to go back to graphing. And what we have already learned how to graph were equations that were already in slope-intercept form. So y equals mx plus b, we already know how to graph. We've been doing that for a few months now. So what we're going to be talking about now is when it's in y equals mx plus b, these are linear equations because of the equal sign. Well, now we're going to talk about how to graph a linear inequality. Remember the greater than or less than or equal to, greater than or equal to. Okay, so a linear inequality, it is similar to a linear equation, but it doesn't use an equal sign. It uses an inequality sign. So you got to know them. Greater than, less than, greater than or equal to, less than or equal to. Okay. A solution to a linear inequality is similar to a linear equation. It is the ordered pairs that make an inequality true. Okay, so when you plug them numbers in, when you plug the x and y number in, if it makes the inequality true, then it would be a solution. For example, determine which ordered pairs are solutions to this linear inequality. 2x minus 3y is less than 15. And the question is this ordered pair a solution to this? So take the x number and take the y number and plug them in and see if you get a true statement. Meaning, when you plug these in, is this side going to be less than 15? So instead of 2 times x, it's going to be 2 times 2 minus 3 times y, but instead of y, I'm using the 5. Is that less than 15? So let's see what we get. 2 times 2 is 4. Negative 3 times 5 is negative 15. Now, I'm not saying it's less than 15. I'm trying to see if it is less than 15. 4 take away 15 is negative 11 is less than 15. Well, any negative number is smaller than any positive number, so negative 11 is smaller than 15. So this would be a solution. Okay. So let's see if we get, let's do this one. 3 negative 4. So 2 times x. So again, I'm using the same inequality. I'm just going to plug these numbers in. Plug the x number in and plug the y number in. So instead of 2 times x, it's going to be 2 times 3 minus 3 times y, which is negative 4, is less than 15. And I'm seeing if this is true. 2 times 3 is 6. Negative 3 times negative 4 is positive 12. 6 plus 12 is 18. And is 18 less than 15? I don't think so. So that's a no. One more. Plug the zeros in. Zeros are easy. Plug the zero in for x and 0 in for y. Same problem. 2 times 0 minus 3 times 0, plugging zeros in, is less than 15. Well, when you plug a 0 in, that number goes away. So this would just be 0, and that would be 0. And 0 take away 0 is 0. And is 0 less than 15? Yeah, I think so. Okay. So that's how you see if an ordered pair is a solution to an inequality. You plug it in and you see if it works or not. Sometimes it'll work. Sometimes it won't. All right, so if we're going to talk about graphing now, what you need to do is remember your BFF when it comes to graphing. This guy right here. So you're going to want to put the inequality in that form, which is slope-intercept form. Okay, if it's in slope-intercept form already, meaning y is by itself on one side, then it's good to go. If it's not in slope-intercept form, then you'll need to move it around until it gets in slope-intercept form. Now remember, the only difference between this and what we're talking about here is rather than an equal sign, you're going to have an inequality sign. Okay, so big rule, which still applies. It applies always to inequalities. Be sure to flip the inequality symbol if you multiply or divide by a negative number. Remember that rule? The one special rule with inequalities. If you ever multiply or divide both sides by a negative number, then you have to flip the sign. Okay? Now, there's some other stuff that you have to remember with an inequality. Remember the open circle and closed circles with the greater than or equal to? Okay, well, when we graph these, and you'll see these in use here in a second. So we're going to use a solid line for a greater than or equal to or a less than or equal to. Remember the closed circle? When it had the equal bar, it was a closed circle. Well, when you have the equal bar, you're going to have a solid line. If there is not an equal bar, if it's greater than or less than, you're going to use a dotted line or a dashed line or an open line. These had open circles, right? Well, you're going to use a dotted line that would look like this. So the solid line would look like we always do, and the dotted line would look like that, or a dashed line. And then lastly, remember when we were doing inequalities, you had to draw an arrow to the left or to the right showing where the solutions were? Well, in this one, we're going to do the same type of thing. It's related. We're going to shade, and I'll show you what this means here in a second. We will shade above your boundary line if the symbol is greater than or equal to. Think about it. Greater than means bigger. So above means above it or bigger. We will shade below the line for less than or equal to. Okay. So I'll show you what this means. So look at this example. This example here is not in slope-intercept form. 2x minus 3y is less than 15, and I need to get it in this form, except it's not going to have an equal sign. It's going to have an inequality sign. So I need to get y by itself. So the steps are still the same, what we were learning all the time. Take away the 2x, take away the 2x. This doesn't cause me to change the sign. I'm left with negative 3y is less than, and remember, put the negative 2x first and then the positive 15. You can't put those together because one has an x and one does not. Now to get y by itself, I simply need to divide by negative 3, which would get me y by itself. And I want to divide everything by negative 3. Remember, if it will divide, then go ahead and divide it. And if it won't, leave it as that fraction that you created. I'm dividing everything by negative 3, which means I'm going to have to flip the sign. Please don't forget that. This, negative 2 over negative 3, this will not divide evenly. So I'm going to leave it as a fraction. But remember, there's one thing you can clean up on here. What's a negative divided by negative? Well, that's positive, which means that I'm going to write that as a positive 2/3 rather than a negative over a negative. This will divide. 15 divided by negative 3 is negative 5. And now I have my inequality in slope-intercept form. So what is my B number? My B number is negative 5. So that's where I'm going to begin at. 1, 2, 3, 4, negative 5. And then from there, I'm going to rise over run. This doesn't change. These steps you should know. Rise 2, run 3. Rise positive 2, run positive 3. 2, 3 takes us off the graph. And now I'm going to draw the boundary line. And this is where it starts to change. If your inequality sign has a bar underneath it, like this, then your line will be solid. But this one does not have a bar underneath it. So we're going to use a dotted line. So rather than just drawing a solid line like I'm always used to, this time I'm going to draw a dotted line to show that boundary line. So now I have a dotted line rather than a solid line because there's no equal bar. And now lastly, remember when we were drawing the arrows to the left or to the right on an inequality? Remember on a number line, we had our object number, and then we were drawing an arrow to the left, or we were drawing an arrow to the right or to the left, either way. Well, it's going to be similar to that, okay? But we're not drawing arrows, we're shading, meaning that we're going to color in either everything above this line or everything below this line, depending on the symbol. This symbol is greater than. Greater than means bigger. So bigger means Or would you think we would go above the line or below the line? I'm going to go above it. Bigger means above. So bigger means everything above this line. So when I say shaded in, we have all of that shaded in above. I'll color it in a little bit more. The whole graph, everything above that line. What this shaded area represents are all the ordered pairs that are solutions to this. So remember when we were doing these, we said 2, 5. This was the same inequality. We said 2, 5 was a solution. Well, the ordered pair 2, 5 is 1, 2, 1, 2, 3, 4, 5, right up here. And sure enough, that's in the shaded area. Remember we said 3, negative 4 was not a solution? Well, if I go to 1, 2, 3, and 1, 2, 3, 4, I'm right down here in this clear area, which means these ordered pairs are not solutions. So this is how you graph an inequality. Make sure it's in slope-intercept form, like we did here. Use a solid or a dotted line, and then make sure you shade above or below. And then the question I always get is, do we have to shade if you see one that you're asked to graph? If it's an inequality sign, you always have to shade. If it's an inequality sign. All right, let's work a couple more. This one's already in slope-intercept form. Number 1, where would I begin at? Okay, hang on. It's in slope-intercept form because y is all by itself on one side. So I would begin at negative 5. 1, 2, 3, 4, 5. Always on the y-axis. That's my B number. And then I'm going to rise over run. Up 1 over 3. Up 1 over 3. Remember, I can also go down 1 and left 3. And now I have to draw my boundary line. And because this symbol does not have an equal bar underneath it, it's going to be a dotted line again, or a dashed line. So I'm drawing a dashed line here. Now my shading, greater than. So again, I'm going above the line. So I'm shading the whole graph, everything above this boundary line. So again, these points would be solutions and these would not. Let's look at one that's a little different, but similar. This one's already in slope-intercept form. I would begin at negative 1. From there, my slope is negative 2 over 1. So I would go negative 2, down 2, and right 1. Negative 2 and right 1. Or I could go up 2 and left 1. And now I need to draw my boundary line. And because this inequality sign has an equal bar underneath it, my line now will be solid, just like I'm used to drawing. And now my shading, less than or equal to. Less than means smaller, so I would go below the line. So below this line would be over here in this area. And if you have trouble figuring out what is above and what is below, put your pencil on a point on the line and then go 1 unit below, straight down. And now you can see where you're at below. You're below right here. So below the line, everything below this line. The whole graph below that line. That's going to be the graph for that. So all these ordered pairs are solutions, meaning if I plug them in, they would work. All of these ordered pairs are not solutions. Okay. Let's try one of these. Let's graph number 4 real quick. I got to get y by itself in this one. So I'm going to take away x. Take away x, so I'm left with negative 4y is less than negative x plus 8. I'm just subtracting x. Here I need to divide by negative 4. This is a tricky one, so you might want to watch. These cancel out, leaves me just y. I divided both sides by negative 4, so I'm switching the sign. Negative 1x over negative 4 cannot divide. Negative 1 over negative 4, but a negative divided by a negative is a positive. So I'm going to leave that as 1/4 x instead of -1 over -4. This divides to be -2. Now it's in slope-intercept form. I'm going to begin at -2. And from there, I'm going to go up 1 and right 4, up 1 and right 4. Or I can go down 1 and left 4. And now I can draw my boundary line. No equal bar. So will it be solid or will it be dotted? It's going to be dotted. Greater than. Am I shading above or below? Above. So everything above it. There you go. Special cases. Remember when there's only one variable? Yeah, you're going to get these again. Sorry. Y is less than or equal to -4. This will be a horizontal line passing through the y-axis at -4. So I'm going to draw a horizontal line, and it's going to be a solid line. You have to remember that every time. See, that crosses through the y-axis at -4. And I'm going to shade, well, this is less than, so I'm shading below the line. So I'm going to shade everything below that line. Okay? X is greater than 7. This line will cross through the x-axis at 7, which means it has to be vertical to cross through the x-axis. 1, 2, 3, 4, 5, 6, 7. Positive 7. Right there. So it's going to cross through that. There is no equal bar, so it will not be a solid line. It will be a dotted line. And now my shading. For this one, there is no above or below because it's a vertical line. There's only left or right. But if you look at the problem, I think you can probably figure out which side. X is greater than 7. Numbers that are greater than 7 are over here, not these numbers. So I would shade over here. Okay, make sure it's in slope-intercept form first. Make sure you take into account whether it's a solid line or a dotted line. And make sure that you shade above or below.